Assalamualaikum, madam. My name is Abdul Hafiy Kamaluddin bin Durrani. My matrix number is 101476. We are from Team Infinite Loopers from Group 03. So managing urban waste efficiently is a growing challenge, which is why we developed the Smart Waste system for the Kuching City Hall, DBKU. Our project is an intelligent waste collection and monitoring system designed to optimize collection routes and provide real-time data on bin levels. It is by integrating smart technology into public sanitation, we aim to reduce operational costs for the city and create a cleaner, more sustainable environment for the community.
Assalamualaikum and good morning to Madam Jane. My name is Syazwan bin Salleh. Matrix number 102208 are going to present our project MOV and scope. So there are four areas of impact we want to cover with each customer. We want to increase the customer satisfaction by 30% through efficient operation and cleaner service. We want to decrease the financial problem by decrease operational costs via optimized collection route and reduce fuel consumption. We want to increase productivity, the operational, with automatic scheduling and real-time monitoring. And for the social, we want to decrease public dissatisfaction and reduce carbon emission by negative 25%. So what our project value proposition is we want to make it better by increase the quality improvement by 30%, increase in collection productivity. We want to make it faster by increase the efficiency by 57 in operational time. And then we want to make it cheaper by reducing that cost by 30% in operational expenses. This is aligned with Sarawak Sustainability Blueprint 2030 quote transform DBKU's waste management from a reactive cost center operational to a proactive, data-driven, and sustainable public service. That's all from me. Move on to my next team member.
Our original project plan for the Smart Waste system established a solid baseline with a 130-day timeline and a budget of RM 200,000, spanning from January 6th to July 7th, 2026. This initial framework utilized a full insourcing model to maintain internal control across 9 distinct phases, leveraging a robust tech stack of LoRaWAN IoT and the Flutter framework. While this plan was designed for a controlled, milestone-driven development process with standard 5-day work weeks, it served as a critical alternative C reference point before we began addressing the client's subsequent requests for schedule compression. So to meet our new 117-day deadline, we have implemented a 10% schedule reduction through strategic fast tracking and crashing by overlapping design work with project planning and utilizing crashing techniques such as assigning senior developers and using pre-built API framework. We successfully shaved 13 days off the original 130-day timeline. Key efficiencies were found in the analysis and design and construction phases, while critical stages like initialization and closure remain untouched to ensure system stability and quality.
Hello, my name is Durrani Ammar bin Kamaruzaman with metric number 97372. So let's take a look at the breakdown of our revised budget. Our goal was to hit a 20% reduction, bringing the total cost down to 160,000 from 200,000 ringgit. Here is exactly how we got there. So for the first, hardware and infrastructure. Originally just over 100,000, we have brought this down to 81,242 ringgit. We are doing this by focusing the installation as exclusively on the Samariang zone rather than a scattered approach. This reduces our cabling and hardware volume. So for the software development, we dropped this from 33,000 to roughly 26,000. Instead of building everything from scratch, we are optimizing by using pre-built widgets. Then we have labor. Because of the geographic area is smaller, our IoT deployment drops to 12,000 less travel time between such main focus installation. So for the management and training, we trim project by management by consolidating our meetings, schedule fewer for more effective meetings. And for training, we are moving to digital manuals, which cut the training budget by 30%. So looking at the bottom of the slide, our strategy relies on three pillars: reducing scope to high priority zones, optimizing tech with open source framework like ThinkSport, and increasing process efficiency. We are confident we can deliver the project successfully within this new 160,000 limit.
Hi, my name is Ahmad Immil bin Ahmad Rushdan with a metric number of 101490. Now, let's move to the proactive risk mitigation framework. Our objective here is ensuring comprehensive coverage across all project phases rather than just reacting to problems as they occur. Looking at the table, we have assigned specific owners to mitigate risk at every stage. In the conceptualized phase, me, which is Izzat, is controlling a 20% budget cut by strictly prioritizing scope. Through project charter and execution phases, we are mitigating risks related to hidden costs and sensor failure by allocating contingency reserves and prioritizing critical hardware components. In the closed project phase, Abdul Hafiy is managing people risk, specifically burnout, by cutting non-essential tasks to focus solely on the critical path. Most importantly, I want to draw your attention to the final phase, evaluate success phase, highlighted here in gray. We face a significant quality risk here, which is our compressed 117-day timeline could lead to inadequate staff training. Our mitigation strategy, led by Muhammad Arif, focuses on creating comprehensive digital tutorials. This ensures staff have constant access to training materials without delaying the rollout, balancing our risk across scope, budget, technology, and people. Next, for the system conversion, we evaluated three standard models to determine the best fit for our constraints. We ultimately selected a phased implementation strategy, as it offers the safest and most cost-effective path forward. To briefly explain why we chose this path, we rejected a direct cutover immediately because the risk was simply too high. An instant switch leaves no backup and risks total service disruption. We also rejected a parallel adoption, which is running both systems at once. While safer, it requires double the manpower and resources, which directly conflicts with our budget and schedule constraints. The phased approach creates a low risk environment. It allows us to identify issues early in small batches and let our users adapt gradually, which is reducing resistance. Our specific roadmap for the SmartWaste system consists of 4 manageable steps. We start with Phase 1, deploying sensors in the Semarang zone as our pilot. Phase 2 focuses on the workforce, rolling out the app and training for drivers. Phase 3 brings the administration online with the operations dashboard. And finally, Phase 4 completes the project with full system integration and scaling.
My name is Muhammad Arif bin Saji and my metric number is 99895. For this slide, I will explain how we ensure the project is properly closed and how we evaluate whether the project has achieved its MOV. First, we use a 27-point closure checklist to confirm that the project is fully completed. From an administrative perspective, all deliverables are completed and accepted by DBKU. Final reports are submitted, documentation is archived, and project resources are released. For financial closure, we verify financial records, complete vendor payments, ensure there are no outstanding commitments, and officially close the project account. From a technical perspective, finance system is completed, critical bugs are resolved, system performance is validated, the system is deployed, and a proper technical handover is conducted. After closure, we evaluate success using MOV evaluation summary table. Customer satisfaction targets a 30% increase, operational costs aim to reduce by 35%, productivity is expected to increase by 40%, and operational time is targeted to reduce by 57%. Finally, social impact is measured through a 20% reduction in public dissatisfaction. In conclusion, disclosure and MOV evaluation framework ensures that project success is clearly measured and proven.
So for the final part, to optimize our delivery, We successfully transitioned from an original 130-day for RM to 200,000 baseline to a linear 117-day schedule. This 10% timeline reduction was achieved by applying fast tracking to overlap design with planning and crashing the construction phase using pre-built API framework. Simultaneously, we made a 20% cost reduction demand, saving RM 40,000 through strategic scope refinement and resource leveling without sacrificing the project measurable organizational value MOV. By focusing on high-density zones and a phase conversion strategy, we have integrated these efficiencies into a framework that ensures a safe, validated deployment. That's all from us. Thank you.